Baru. Okay, my name is Karvinti. My metric number is CF170041, and then today I will be present the introduction our infrastructure projects and under IDP projects. So this project is under Jabatan Pekerja Raya is proposing about the construction of the terrace house. So the project title is the purpose of the construction 140 terrace house and most. So at a lot 2436 GM 1451. So the owner of this developer is Jabatan Kerja Raya. So as usual is our clients. Okay. The location of this project is in Mukim 10 at 3200 Senggarang Batu Pahat Johor. So project duration is 36 months and then project cost is 5 millions. Okay, our client is mentioned before is the Jabatan Kerja Raya. So the architecture is under Archive Perunding Sdn Bhd. So the town planner is the Senggarang Municipal Council Office, and then MME is under Mechanical and Electrical Consultant, and then QS consultant is under QS Link City Consultants, and then the civil structure is under the civil structure consultant. Okay, now I will be present about our project schedule in this proposal. For the week 1, the description before is as usual. I have described a description before. We have the invitation project, preliminary infrastructure, weekly discussion, and the calculation. So for the week 1 and week 2, we need to finish up our invitation project is the cost of fire briefing, infra calculating briefing, allocate existing drawings, and then the check and drawing plannings. For the week 3, we need to prepare the preliminary infrastructure. So it's before the design of the cut and fill and the design of drainage and the water detention pond. For the weekly discussion, we do from the week 1 until the week 10 about the work commencement on infra reports. So for the calculation, we take the longest. We start from the week 4 is mentioned. For the earth calculation, we do and finish at the week 4. The road and drainage calculation, we start at the week 5 and finish at the week 5. And then the sewerage reticulation design, we start at the week 6 and finish at week 6. And then during the week 7 and until during the week 7, we start the water reticulation design and build quantities. So we need to calculate the cost and the propose. And then for the week 8, we need to prepare the video presentation. Week 9 at the week 9, we need to answer and the question answer season. And then for the week 10, we need to question and answer season and submit the project report. So okay, for the build infrastructure, for have item for the item earth clearing site, road structure, water regulation, sewerage pumping, and the surface and water drainage, and other. The other is about the drawing, the cost of the drawing we need to prepare. So we need to pay another. We need to pay and the preparation about the salary for and then the cost for to rent another workers. Okay, for the earth clearing, we need 147,000 and 12 ringgit 50 cents for this earth clearing. We propose this cost. And then the road construction, we need 193,000 400 552 ringgits, and then the for water reticulation is 41,000 21,315 ringgits. So the sewage pumping we need 165,000. For the surface water drainage we need to 49,265 ringgits, and then in another we need to 5,000. For the total of the this cost is the 510,794 ringgit and 50 cent for a total of these projects. So that's all for me. I will be another will be presented by my friend. Thank you.
Hi everyone, today I would like to present about the earthwork design of our project. In the civil engineering construction project, the movement of the large amount of earth for excavation, cutting and embankment may be substantial parts of the overall project. For our project, we were using the grid method to calculate the cut and fill volume. So this is our earthwork plan for our project. From this plan, the grid line will be shown so that we can read the value of the existing level one by one from the control and put in the Excel, so that the Excel will help us to count which area need to fill, which area need to cut. After we calculate, so we know that red the red color one is the area did not to fill, and the green color one is the area did not to cut. The reduced level, existing level and platform level for the building and road will be shown in this drawing. So this is the example of Excel we use to calculate. Our total construction area is 74250 meters square, and after done all the calculation, the total cut volume and the total fill volume and the total import fill volume and the excess cut volume will be shown in the screen. That's all from me. Thank you.
Hello, my name is Ashmi. I would like to present my part on drainage system. Okay, it is recognized that a road requires a drainage system to deal with stormwater runoff. Therefore, the drainage system becomes an important and integral consideration in the planning and design of road infrastructure. In order to provide an appropriate and economic drainage system, all road projects, irrespective of location, size, cost, or complexity, must be considered and address the following aspects, which is the provision of an acceptable level of flood immunity and accessibility, and also the impact of flooding on public and private property. So as you can see here, this is the drainage system that we have been proposed. So actually we have proposed sub-drains around each of the buildings and also around this masjid. So there is also culvert between sub-drains, so that the water will go to the sub-drain and then it will flow into the main drain. So this is our water tank, and this one is our detention pond is a place where the collection of water happen. So we from the water will, for example, if we take into consideration of this building, there is sub drain surrounding, so the water will flow to the sub drain, and from the sub drain it will flow to the culvert, from culvert to the main vein, and then the water will eventually will flow into the detention pond, which is the storage pond lah. Okay, so we also made calculation for our drainage system. So this is our calculation sheet that we have designed. We have designed for 5 years. As we all can see from the plan, we have designed our drainage system at Batu Pahat, Johor. So we have taken the value of A, B, and C and D according to our selected location for 5 years. And then after we have calculated the overland distance, which is 7 meter. Drain distance is 121.78 meter, and also we use the stormwater duration adjustment factor of 0.01. So at last we have obtained the catchment area is 1.43 hectare, which is equal to 0.0143 kilometer square, and our peak discharge is 2.221 meter cube per second. So this is our main design calculation. So in this main calculation, we have used the ratio of the gradient for the slope is 1:500, and we use the width of 600 mm and size of drain is 300 for all the sub drains, and we use the velocity is and we use the capacity of 0.35. For the capacity of 0.35, we use the manning coefficient of 0.011. So as you can see here, according to what we have proposed, our subdrain, all the subdrains have the past values. After that, we also designed the storm water management. Okay. Okay. So for the stormwater, the main objective of stormwater management is to check the adequacy of open space provided in the overall layout plan. And to determine the site-specific stormwater management requires to ensure that the proposals are in conformance with the proposed stormwater management requirement, and also to evaluate the various stormwater management practices that meet the requirements and recommend preferred strategy. So before that, I will show our detail of drainage, culvert and sump. Okay, this is the detail of drainage that we have been proposed. So this is the measurement, the height and width of drainage, and this is our proposed box culvert, and this is our sump, detail of sump. So this is the front view of sump, and this is the plan view of the sump. So you can see this one is the length, and then this one is the height of the sump. Okay, so we also made some calculation for the OSD tank, which is an on-site detention tank. Okay. As we can see here, we have calculated the permissible site storage per hectare, PSC per hectare, which we obtained 45.7 hectare. And based on the figure 5.82, we have obtained the site storage requirement SSR per hectare, which is equal to 373.6 meter cube per hectare. The inlet flow per hectare is 148.6 liter per second per hectare, which is if we converted, we will be getting 0.702 meter cube per second. So after we calculate the inlet and outlet pipe, this is our PSC. We have obtained 215.9 liter per second, and for SSR we have obtained 1765.3 meter cube. So the sizing of ORC tank, the required storage is 1765.3 meter cube. So we adopt the width of the tank is about 36 meter, 25 meter of length, and depth of 2 meter. So, and then finally we have obtained that the inlet pipe that we want to propose for our OSD is 500 mm diameter pipe size, and for outlet pipe is 400 mm diameter pipe size. So that's all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Zubaida binti Syekh Kamalul Arifin, matrix number CF170197 from Group 5, will be presenting about the sewerage design. In this project, we propose to use 16 numbers of manhole, and these are the location of each manhole. So I will start to explain the sewage flow from each manhole. The sewage from manhole 1, which is the nearest to the masjid, will flow to the manhole 2, and it will continue to flow to the manhole 3. The sewage from the manhole 4 also will flow to the manhole 3. Then it will continue from manhole 3 to manhole 6, and manhole 7 to manhole 6, and manhole 5 to manhole 6. Then from manhole 6 it will continue to flow to the manhole 9, and manhole 10 to manhole 9, manhole 8 to manhole 9, and continue from manhole 9. The sewage will flow to the manhole 12, manhole 11 to manhole 12. The sewerage from manhole 14 will flow to the manhole 15, and the sewerage from manhole 16 will flow to the manhole 15. And after that, the sewerage from manhole 15 will flow to the manhole 12 and will go to the manhole 13. After that, it will flow to the discharge point. The value of ground level and the distance between each manhole were determined. The population equivalent also has been estimated based on the type of premise. For the design calculation, first we calculate the peak flow factor, PFF, which is the formula are 4.7 divided by the cumulative PE over 100 power of 0.11. For the dimension of pipe, we choose 2 to 5 mm, which is we try from the smallest dimension. And after that, we calculate the average flow rate, which is Q average, equal to per capita daily sewage flow generation. And then we calculate the peak flow, which is the peak flow factor times by the Q average. For the velocity value, we calculate using the Manning equation, which is V equal to R, hydraulic radius, power of 2 over 3, times by S, hydraulic gradient, power of 1 over 2, divided by N, which is the Manning coefficient. In this project, the Manning coefficient that we choose is 0.014. For area, we use the formula pi d squared over 4. For the weighted perimeter, we use pi r squared. And for the slope, 1 to n, which is n varies from the 0.5% or 50 to 4%, which is 400. And in this project, we use 1 to 200. Next, calculate the hydraulic radius, which is area divided by the weighted perimeter. Next, we need to find the value of fall for each connection of manhole, which is the formula 1 over 2000 times by the length of a section of manhole. So, to get the invert level, we use GL value that we get from the drawing, which is from the contour, and we minus with the first purpose depth, which is 1.2 meter. Next, to find the invert level of the second manhole, GL value minus by the first depth that already has been added with the fall value. So if there's any connection between manhole, in example like this, manhole 2 to manhole 3, manhole 4 to manhole 3, the outlet level of manhole 3 must satisfy to connect with the manhole 4 and manhole 2. The invert level at the manhole 3 must lower than the manhole 4 and manhole 2, so that the sewerage water from manhole 2 and manhole 4 to manhole 3 can be flowed.
Assalamualaikum and hello. My name is Siti Haisal binti Muhammad Hatta, and I will present about water supply. So for our project, we propose construction for terrace house building at Senggara Batu Pahat Johor. So first I will show you a slide presentation to explain about the calculation, and the last one I will show you water supply plan design for our project. Okay, so we will calculate water demand. So we will refer water demand guideline. So average rate gallon per day is 300 130, so this one we take it from here for double storage terrace house. So our unit is 140, so times 330, so we get water demand gallons per day. So this is terrace house building, so our area here. So this is the table for peak factor required. So for this design we will take 2.5 because this project was located at urban area. And for firefighting floor, for our project is class D because building types is terrace house, so average total flow is 1140. So next, so this is daily water demand calculation. So this is a formula. So average flow rate, okay, we get it 0.535 liter per second. So peak flow rate formula is average time peak flow rate. And then for fire flow rate, the formula is average flow rate plus hydrant flow. So hydrant flow 1140 is based on MWA from the table just now. So fire flow rate we get it 0.0195 meter cube per second. So next is okay, so for this project we using is Hazen William formula method, so to get the value of head loss. So okay, this one is the table after we calculate. So this is pipe length, so this is length from node 1 to 2, node 3 to node 2 to 3. So and this is 5, and this is pipe, so we have 32 pipe. So this is the value that we calculate for manual calculation. Okay, so for the last one, I will show you the water supply plan design. So this is our plan design for water supply. So for this design, we propose 160 millimeter UPVC pipe. So that's all for me. Thank you.